Okay, what you're gonna learn now through an applet, the logic of hypothesis testing, how it works. So let me give you the problem and then I'll show you how the applet works. There's a politician wants to know if a majority means more than 50% of the voters in her town will be in favor of her policy. Rather than hiring, a firm to conduct a survey and survey people on the streets, what we're gonna do, we're gonna simulate the experience, the experiment using the computer and using the applet. If they go on the street and ask people either gonna say yes, I am in favor, or no, I'm not in favor. So it's a 50-50%. Rather than doing that, we're gonna survey 500 registered voters by tossing a coin 500 times. If the coin lands on the head face up, then we're gonna assume that it's a yes, I am in favor of the policy, and if not, then I'm against the policy. So let me show you how the applet works. But what the politician wants to know, as you can see, H1, she wants to know if the percent of people who will be in favor of policy is more than 50%, or majority means more than 50%. So that's the claim right there. P is greater than 0.5. Let me go to the applet now. We're gonna click on it. Okay. Here's how the applet works. So we're gonna simulate. We're gonna toss the coin 500 times. You're not gonna see it. This is gonna happen in a fraction of a second. So what the applet is telling me, just click. The instruction is saying click one run. One run means you're gonna toss the coin 500 times and record the number of heads. The number of heads is the number of people who would say I'm in favor of the policy. So I'm gonna click one run here, and you can see how many heads here. Let me just click on it again. 243, 257. So 243 said yes, and 257 said no. What's the percent of people who said yes, we are in favor of policy? It's 243 divided by 500, and which is about what, 48.6%. Okay, let's keep this in mind. So let me close this one, and this is the question. So part A, simulate obtaining a simple random sample 500 voters. Assume that P is 0.5 exactly one time by pressing one run. That's what I did. In this simulation, we are flipping 500 coins where each coin represents a voter. The probability of obtaining a head is 0.5, and the probability of obtaining a tail is also 0.5. So how many registered voters are in favor of the policy? I just showed you. If I click on one again, it's 243. Let's go to the second part now of the applet, which is part B. Okay. Simulate obtaining a second simple random sample, assuming that P is 0.5 by pressing one run a second time. So let me just go to this. I'm going to click one run a second time. And now how many heads did you get? 258. Let's click on it one more time. 258 who said yes, and 242 who said no. Did you notice here that if you pick a different sample, the number of heads is going to change from one sample to another, is not going to be the same. But they seem to be close to 50%. Okay? So let's now go to part C. Okay. Suppose that the polling firm actually conducts a survey of 500 registered voters and find that 260 are in favor of the policy. So P hat is the sample proportion. How many said yes, that we will favor the policy? Is 260 out of 500, which is 0.52. Do you believe that this sample evidence suggests that the true proportion of registered voters in favor of the policy is greater than 0.5? So because we got one sample that gives me something more than 50%, can we make a conclusion about the entire population that more than 50% of people are in favor of this policy. Well, let's check if this is the case. Well, this is only one sample. What about if I run another sample and I don't get, something more than 50%? Can I still make a conclusion that yes, actually the percentage of people who would vote in favor of the policy is more than 50%? So we're gonna run a simulation here, and so it says click 1,000 runs here. 1,000 runs means you're gonna survey 1,000 samples, and each sample is of size 500. So you're gonna do it 1,000 times. Okay. Let's see. Let me go back and see. So I'm gonna reset this. I'm gonna do 1,000 runs. Okay. Number of heads, we want that to be 200, more than 260. How many of the 1,000 samples that we just ran here resulted in number of heads more than 260? It's only 203 samples out of the 1,000, and the proportion is about 20%. It's 203 divided by 1,000. So are you guys convinced? Maybe it's not the case that the majority of people are gonna be in favor, because out of 1,000 samples, only 203 samples had 260 people, more than 260 people said that they will be in favor of the policy. Okay, let's see what's next. Okay, let me go back to the right here. Okay, part D. What about if we said we want to see if more than 270 would say that they are in favor of the policy? Let's simulate that. So I want to go back to this. Oops. Okay. Let me reset. You do a reset and then change the 260 to 270. So now we're gonna simulate 1,000 samples, each sample of size 500, and we're gonna see how many of the 1,000 samples, how many samples have 270 resulted in more than 270 heads. So just click 1,000 runs. Only 42. What is this? It's about 4% of all the samples resulted in something that's more than 270. Okay. Just keep observing. Part E. Now he says, let's say we want to see if more than 280 would say that out of each 500 would say we are in favor, just of the policy. So I'm going to simulate that. Oops. Click on the applet again. Part E. Okay, so I'm going to reset. And then I'm going to change this to 280. Okay, and 1,000 runs. 1,000 runs means we did 1,000 samples, and from each sample we counted the number of heads, but it's all done in a fraction of a second. This is the beauty of technology. You see how many samples out of 1,000 resulted in samples that had 280 yeses out of 500? It's only 5. So what's happening to the proportion as we increase this number? It's becoming smaller and smaller. So now we can go to the questions. Oops. Click. It's okay if you can see the answer, because I wanted to understand that. So based on the simulations, what is the center of the distribution? The center of the distribution is the mean, and you learned that the mean from chapter mean of the binomial distribution is n times p. N is 500 and p is 0.5, so 500 times 0.5 is going to be what? 250. As you notice, when I showed you the 1,000 runs, you saw a normal distribution, and in the middle that was the value of 250. So that's a freebie. If you watch the video, you're gonna get the answer to this one. Okay, here. In this simulation of part C through E, we increased the sample proportion. You see, we went to 60 out of 500, then we went to 70, and we went to 150. What happens to the number of simulation that result in a sample proportion as higher or higher in favor of the policy? Did you notice that out of 1,000 we had first time 200 samples, next time we had 40 samples out of 1,000, last time we had 5. So what happens to the number of samples? It decreased. So you know the answer to this one. And then you're going to go through the steps of doing a hypothesis test in here. So I thought to explain the simulation to you so you can have an idea what this simulation is.